Take it away.
Hi, I'm Chris. I'm this guy. I put this in a slide a couple of years ago. David Baker told me I had to bring it back because of the topic today. So thank him for that. During our talk at EmberConf last July, while we were presenting WarpDrive, someone in Discord commented that it felt like WWDC had come early. I didn't come to Emberfest this year to give that style of talk, so apologies in advance if you were hoping for that level of production quality. That said, though, this is a follow-on talk from that introduction to WarpDrive. And while our talk at EmberConf might have felt really packed, we left a lot on the cutting room floor when we were trying to build that talk out. Just not enough time to fit all of the different ideas into it and cover them. And I still don't have enough time today to get into everything that we left on the cutting room floor that day. So we're just going to try to get into a few in-depths. But this is kind of a follow-on, and I just wanted to give everyone who'd seen that talk one more thing. And even if you didn't see that talk, this talk today is going to be approachable. But if you didn't watch it, I really, really heavily recommend going back and watching it, especially because if you're just getting caught up now, you're probably really confused why I'm up here talking about WarpDrive when I'm runspired Mr. Ember Data. The TLDR, if you haven't picked up on it, is that we are rebranding as part of going universal. There's a lot more to it than that, and we go into those motivations in our talk from EmberConf. But what you need to know today is that conceptually, Ember Data's architecture maps onto WarpDrive. This architecture, so all the same ideas are there somewhere. They're just rearranged a bit. But for the talk today, you should try to forget everything that you think you know about Ember Data, at least for like the next 30 minutes. Last note before diving in, you're going to see a lot of boilerplate today, especially around installing and configuring packages, setting up the main configuration for the app. That stuff doesn't make me happy either. And you don't need to worry about it, though, because there's two things that are true about what I'm going to show today. The first is that it's something that every app will do once, kind of set it and forget it, and you move on. And the second thing is that most of that, I think we're going to get automated via a CLI tool. So by the time most of you are adopting it, probably you don't have to do any of these things very manually. So with that in mind, what is WarpDrive? Well, a few days ago, I sent out a form to all of you. Some of you responded to it. And I wanted to see how you would describe WarpDrive or Ember Data. And I'd be lying if I said I didn't send this out with a preconceived notion of the kinds of answers I'd get. I expected to see a lot of answers describing what Ember Data was. I suspected that even in this educated audience, I was going to mostly get answers along the lines of it being a singleton store service and models. And for the most part, you did not disappoint. There were a few overachievers in the group, and I appreciated all the answers. But the really good news here is this last question down here, you will enjoy Emberfest, had a 100% yes rate. Here's a word cloud of what you thought could be better. And model and documentation really stand out here. Good news is we've been working pretty hard on a lot of new guides. They're still really rough. There's still a lot that we need to build on. There's still a lot of room for improvement. We would love your involvement and help if you have the time. But the even better news is that model's kind of going away, and this talk really isn't going to get into it at all because we don't need it anymore. So a big area of annoyance, biggest area of annoyance is maybe just going to disappear. And here's the top 25 words minus the word data, because I realized I needed to exclude it. But the top 25 words of how you described WarpDrive either to yourself or to others. And cache and store and models obviously feature very prominently into the explanation to this. And the thing is thinking of WarpDrive as just a store or a cache or an ORM can get you pretty far, But if you want to level up your application, it's time to think a little bit different. If I were trying to onboard a new engineer into WarpDrive today using only the most modern paradigms, I'd start with request. And I would tell that engineer that WarpDrive is a library that helps us manage our requests and associated state with a uniform interface throughout our app. Incidentally, that's why we decided to focus so hard on showing patterns around working with requests at EmberConf, and so I really don't want to repeat all those here today. But I do want to dig into what it means to put requests at the center of how we teach WarpDrive and around about how the library itself is architected. So here we have a pretty quick setup for Request Manager, which is at the core of the WarpDrive experience. And we see three of the key pieces. This is a request handler, this is a cache handler, and then this is us making a request. So handlers, for instance, fetch, is how we fulfill requests. The cache handler is basically just a handler with a couple of additional capabilities that regular handlers don't have. And the request method is the main entry point through which everything now flows in a managed process. A handler is basically just an object with a request method on it. When the request manager needs to make a request, it gives every registered handler the chance to either handle or pass along the request. So it's a chain of responsibility style primitive. The cache handler is a handler that is guaranteed the chance to run first in the chain. And it's the only handler that can return synchronously, which is why utilities like getRequestState and the request component are able to sort of magically resolve requests during render when the request is already available in the cache, even though you're using what looks like a promise when you do so. The cache handler is also responsible for determining the identity of a request, and that's what's happening here. Is it said, oh, I realized that I have a URL that I care about because we were a GET request, so I've decided that's your identifier, and I'm going to tell the context that that's the identity for this request. That is basically how the request manager is able to dedupe requests. There's a couple of other capabilities tied into that as well. And it's why you can make the same request from a whole lot of different places in your application and only ever see one of them occur. So that explains the first two things that are happening here on this page, but it doesn't really explain the third. This kind of simple object that we've been passing into the request method is like not so secretly the complete core of the architecture. Whether you're using legacy Ember data patterns or the bleeding edge, every single aspect of what WarpDrive is somehow tied to this interface. And so I want to take a deeper look at that. At the most basic level, this object is just the native request init. Request init is the grab bag of options you can pass into the fetch method if you are not familiar with it. And so it's basically a platform API. It's nothing's unique to us. And then we decorate the URL onto that. Now, you'll notice that the URL is optional. We encourage you building URLs up front when you're making requests, but it's possible to have your handler build a URL or for a handler to fulfill a request by some other mechanism that doesn't involve URLs at all. As long as your handlers understand what it is that you sent to them, like, world's your oyster, it's fine. But since the URL is often the cache key, if you're not using URLs, you need to make sure that there's a cache key via some other mechanism. The next thing that we add onto this is controller, which is an abort controller. If you're familiar with the request init API, you might remember that it has an abort signal on it. So it's a little weird that we can also pass in an abort controller. But the basic reasoning here is that we automatically wire up an abort controller within the request pipelines that any request can be aborted. And sometimes you don't want to rely on the one that we wire up. It's actually nicer to entangle it into something that you already have. So if you pass one in, instead of creating one, we just use the one you passed in and we pipe everything through and set up the forwarding on it. Next, we have data and options. I consider these the grab bag of the interface. There is nothing special about these things. This is like recommended usage versus any behavior tied to it. Nothing. There is no specific contract with it at all. It's your opportunity. Data is really your opportunity to pass in something that you're saying, hey, this is really like, I'm making a post request. This is what I want to have serialized to send along with it for a handler to do, or options is your way to kind of maybe dynamically switch out what a handler's gonna, how a handler's gonna behave. Then we get an opcode or op, and this can really be any string. We intentionally didn't left it open-ended, but it is special. This isn't there's a list of opcodes that the Ember Data Store package, its cache handler, has a list of opcodes that it specifically pays attention to. So examples of that are like delete record, update record, create record. And we use those opcodes, the cache handlers using those opcodes to figure out how does it want to transition the state of the resource. So for instance, if you're used to all the request state flags on a record going, oh, am I loading right now? Or am I deleted? Or am I in an error state? Those state transitions are all getting managed by the cache handler via knowing that, hey, this kind of operation is happening, so I need to do these things. Which then brings us to all the other cache options that we have, which is if you don't want to use the URL as your cache key, you can just provide a cache key here. If you want to tell the cache handler, hey, I want to forcibly go to network, no matter what you've got, you can do that. Or you can tell it, hey, if you have something, give it to me, but please refresh this in the background. Types is really fascinating. It's an array of strings, but really it's an array of resource types. So for instance, like if you were to make a query for user, you might put user into the types here. And then what happens is there's a cache policy that governs when requests become invalid, and you can invalidate by type. So you can say any request that was associated with users is now invalid, and this is how that association occurs. So this is really useful because, like, for instance, with creating new records, a lot of times you don't know which queries they would have appeared in. So we just, the default strategy for us is anytime a new record is created, we just invalidate any query that was associated to that type. Skip cache just says, hey, don't let the cache handler do anything with me. So just pass me on through. Finally, we get these three properties: record, store, and enable hydration. I think if we were to go back and start over again, they would go into cache options. But believe it or not, Request Manager is 3 years old now. So we've had plenty of time to organically grow and already realize the error of our ways. But records is how we handle transactions. So it's a list of the identifiers of all of the resources involved. So if you wanted to do transactional saves, transactional deletes of that list is what tells the cache handler this is what's involved here. So transition state on these things. The store and enable hydration are very fascinating. Enable hydration is basically a flag that says, hey, in the response, make the response reactive. The default is that we're just a managed fetch pipeline. So the default is that you're just going to get back the raw data. But that's not all that useful. This flag is what says, hey, actually, like I want something reactive. Like wrap this in a reactive primitive for me. And then finally, the store property is what tells the cache handler which store instance to use to determine if the request already exists or is stale. And that's a really important detail in there because in Ember, we're used to the store being a singleton service, but that's not really true. It's neither a singleton nor a service. WarpDrive supports multiple stores coexisting. We've planned out APIs for store forks, which are basically their own store instances, but they have a parent that they inherit from. So the cache handler actually needs to know which store to use to fulfill a request at any given time. So we pass it in like that. And in fact, that's all store.request really is store.request is just calling manager.request and adding those two properties. Like That's the magic. So you might wonder, why do we even need store.request? And the answer is just it's super convenient. Like, we're used to having the store service in our app. Most of the time, we only want one of them. So just avoids us having to do a little bit of extra boilerplate, and we move on. But you might ask then, what does the store really do? Like, if it's not really the thing that is the core primitive anymore? And the answer to that is that it coordinates caching data. It is what manages the reactivity when we ask for something reactive back. It manages the instance cache for, like, oh, I've instantiated things to be reactive. And it manages schemas for any of that understand the structure of the data that you've put into it in the cache. So there's really two key takeaways that from all this that I want you to have. And the first is that the store is not the foundational primitive, requests are. And the second is that the store is not coupled with request manager and has no role in request fulfillment. It's actually a whole separate primitive that the cache handler just knows how to use. But you could write a cache handler that used something completely else, completely different to store information. Which brings us to one more thing. A couple of weeks ago, Ignis did a really awesome thing. He converted the Pokedex app to use Polaris patterns. And when I saw this, I was like, ooh, this is a really good opportunity for me to use bleeding edge WarpDrive. So we are going to attempt to do that. So here's where my demo is going to probably spectacularly fail, because we are not only going to do some live stepping through of code, but I'm going to do it on GitHub off of my phone tether. So on his thing, I have PR'd a commit by commit. Let's convert to the bleeding edge of WarpDrive. So the very first commit here, which cool, we are working, was just hey, I happen to use Volta to manage my PM stuff, and he hadn't set that up, so it was really annoying when I went to run pm install in Volta, and it was like, there's no pm version, so I added that. Then what I came in is I wanted to take his demo and make it something that could really showcase a lot of the different strengths of the new architecture. And the demo, like so many demos, was like, well, I kind of need an API, but I'm mostly focusing on showing you some code patterns, not API patterns. So it was one big giant 8 megabyte JSON file that you would load in at app boot and then kind of just like pull data off of in different parts of the application. So I wanted more of a realistic API. So I wrote a little generate script that just took that big file and did a couple of key things. So it converted it over to being more in JSON API shape so that I didn't have to think about doing that in the application later. I wrote some utilities so that basically the slices here is like, I'm gonna say, hey, for in this giant list, for every 48 things, treat it as a slice, and that's how I'm gonna get some pagination out of this. For each page, I'm generating some links and metadata for pagination. And then I end up just generating, like, I think it was like 980 files. So I Git ignored those so that they wouldn't blow up this PR. But basically, I think it ends up at being like 18 pages of 48 results each, and then also every single one of the individual Pokemon has its own individual URL that you could fetch it at. Still just JSON files put into the public directory, but like nice hacky little way to have a little bit more realistic API. And these the links up above are going to come into handy play in a moment. So next, it was time to install and configure WarpDrive. So in my MRCLI build file, I'm using WarpDrive build config. This is what we use for deprecation stripping, feature flags, debug logging, all that kind of stuff. And then the reason I've set this to 99.0 is compat with is a property that says as long as I'm at least to this version or lower, you can consider any deprecation up to this version resolved, so you can strip it from the code base. So I've just basically said, I know what I'm doing here, and you can strip out anything that was deprecated, and I don't care. Static app paths was a little thing that we ended up needing to do later. Probably should have put that in a different commit, but I pulled it out weird. Package.json. Ignis had started to try to use some of the WarpDrive stuff, but the documentation's not great, hadn't gotten very far with it. Was trying to use the individual types packages, but since we're using Bleeding Edge Canary now, like on Bleeding Edge Canary, you can just use the types from Bleeding Edge Canary, so I dropped all those and then installed the packages that we cared about. You can appreciate the really high alpha numbers here. We've been working on this way too long. Ran our install and made sure that our TS config was set up. So again, let's convert it over to that. So the next thing I did was I said, all right, where do I want to start refactoring things? And there was a model for Pokemon and some associated types. So I went and I refactored that to, instead of being a model, to being a schema and various associated types. So originally we had basically some type helpers, and then we had a model. We have these adders here, so base, evolution, and notice that they're objects. This is something where historically Ember Data really didn't have a good story for this. Some people would reach for model fragments, but anything inside of that object wouldn't be reactive historically. You would have to kind of reset the main object to get it to notify. That's not going to be the case in the refactor. In the refactor, still have our type utils, but we start writing schemas for everything. So base stats, we now say you are a type of Pokemon base stats, and we give it fields. We say identity null here. There's a whole schema service documentation plus RFC that has documentation in it around all the different valid schemas. What it means to have a schema with no identity field associated to it is that you're saying that I am a schema for a nested object. So that's what we're going to end up using this for down below. So same thing, name was an object, so now we have an associated schema with its fields. You'll notice that these are JSON, like we're defining these in JS, but these are all JSON schemas. So which means that like if we wanted to, we could be generating these from all sorts of other sources of information and sending them down with our API responses if we really wanted to, that sort of thing. And finally, down here we have our actual Pokemon schema. This is the thing that's going to replace the model. So we call with defaults, which is just something that gives us type ID, that kind of stuff. We have type Pokemon. We have our name. Remember that was another schema that we had defined. So our type is Pokemon name. That other schema that we defined, that's what it points to. And we're a schema object. So this is what gives us nested deep reactivity now. And you can infinitely nest these things. So schema objects can point at schema objects and so on. So you can build out deeply reactive graphs based on schema. Now this is very manual to build out right now. If you wanted to go explore these concepts and build out manually, you could, but the goal is to get to the point that all of this is done by and generated by tooling. So you're not hand curating these big things. And then finally, I just wrote a little helper function that takes in the schema service and registers all these different schemas to it that we could call later. Everything else in this particular commit was just changing the type imports over. We had a little store service. I just deleted it and kind of started over. So import store from Ember Data Store, extended that one, and then we started building it out. So the first thing I did was said, okay, we need a request manager. So grab the request manager, grab the fetch handler, use the cache handler. Because all of our URLs are going to end in .json because they're actual JSON files, I realized that we were going to need a custom handler, so we wrote a custom handler. There actually was one already, but I wanted to improve it a little bit, so it's kind of just shifted that. So we added that into our chain, and then our custom handler, what it's going to do is grab the URL, add .json to it. That's all it's doing right now, and we're going to extend it later. Next thing that we want in our store is a cache policy. This just tells us when any given request has expired. I mentioned the default cache policy has invalidation events based on create record, but it also just uses a time-based strategy. So I went with a really big time frame here. So hard expires basically means if you encounter a request older than this, make sure you load before you return. Just consider it invalid completely. Soft expires says if it's past this time, reload it in the background, but otherwise you can return and use the data that you've got. What good is having a store without a cache? In our case, we are working with some JSON API data, so we import the JSON API cache, and we tell the store that, hey, you're going to use this cache. Next, we say, oh, we need to tell it how to understand our schemas. So we say, this is how we're going to create a schema service. So we import the schema service from schema record. We create a new one. We register its defaults. It has a couple of useful things that we're going to end up wanting. And we register the schemas that we had just created ourselves. Now, the thing is, I'm doing all this in the setup. The design is that you can load schemas in at any point. So like, you don't have to have all the schemas available to you at boot, right? Like it can be as either lazily loaded or fetched or delivered by API at any time, as long as you have them by the time you need them. So it's just in time by design, which means that as you build and scale an application, you're not incurring a really big boot cost like you do with models, where all at the very beginning you have to take every single model of however many you have and all that JS code and start parsing it right away. You don't ship, there's no code to ship, there's no models to parse, it's just already there and ready for you. So next, we want to add that reactivity layer. So schema record is the thing that understands how to take the schemas and display it and make it reactive. And so we say, hey, use the instantiate record hook. So anytime I need to instantiate a class for a given resource, this is how you do it. Same thing as anytime you need to destroy one, this is how you get rid of it. The model package, by the way, has corollaries to everything that I've just shown for schema, instantiate record, teardown record. And when you use the Ember data package, the store in it is just doing this configuration using the model packages version of these things. So it's actually the same architecture, but just swapping out the components here. We are going to use a builder to generate some queries, and this just tells the builder, hey, when you're creating a URL, this is the host and namespace to use. And in our case, since we're serving this locally and those JSON files are going to be coming back from our local API asset kind of directory, I just went ahead and said, okay, build URLs to just point back at myself. Right. So then I needed to actually start changing some app code. So the initial implementation of this is just assuming that we are at boot loading everything. So I couldn't make that assumption anymore. So I removed the assumption that we have access to all data. We'll gain access to what we needed that for a different way. I updated the request. Before it was using kind of like a REST builder, which you can see up here. I moved it to using the JSON API builder because of the URL structure and the data format involved. And then because we're using a pretty custom API for the single resource path, I kind of like just overrode the resource path to say, hey, go here on the request. So this is the initial request. When I generated the files earlier, I generated two identical roughly identical files for the first page of results. One is this list.json, and another one is like list/1.json. Because like to replicate the fact that a lot of APIs, like you will call like /users, and it might give you everything, or it might give you page one, and you kind of have to figure out from the response, and sometimes multiple URLs map to the same thing. So we end up doing the same thing here just to replicate that, just for fun. Next thing I did is in the individual Pokemon screen, before it was just kind of reaching up into the parent model that had loaded everything and then filtering down to find the one record it cared about. Now we just make a request to go find that single record using the API that we generated. One of the things to note here is when we're returning these, we're not awaiting these requests, and we're not returning the request. We're wrapping it in objects currently. It's because we wanted to show usage of the request component in the demo. And so we are using this to opt out of the model hook's default semantics of awaiting a promise that you return. So you're going to immediately return from the model hook here and let the template handle all of the state. And then I had to refactor a few of the templates to deal with pagination. This particular component has a little bit of boilerplate that is going to go away as we get further and further into the story of what WarpDrive Ember is. We have some pagination primitives coming, but in the meantime, I just created a little class that says I have a list of pages, my data property. When I add a page, I'm just adding the page onto my list of pages, and then I can add its data onto my data, so I just have an ever-growing array, and that's all it is for now. And then we get into some interesting patterns. So page collection is going to use get request state off of our initial request. If we don't have a result yet, we return null. Once we have a result, we return a new pages. So that means that the result of that initial request is basically the key for our particular pages class. We've added a last reached function so that anytime we hit the end of our list, we can go load more. And this is where the URLs that we set up when we were generating the new API start paying off, because all this code is doing is saying, hey, get me the very last page, right? Go get the list of pages, get me the last page, and call next on it, and await that. I don't have to do any additional TypeScript stuff to say, hey, this is the return type, because it's going to pick all of that up from the initial request. And it just works because of the links that were there in the response. So this is a feature of the request paradigm in WarpDrive that store.query in the old days could not do so nicely. In the template, I switched it over to being the page collections data property that we were reaching over, and we no longer needed to do as Pokemon content because it's just all available in here now. So for the individual Pokemon page, I mostly just got to go delete stuff. Because it had done a whole lot of stuff to figure out, hey, pull off the list and figure out by ID what my actual Pokemon is. And now I can just use the Pokemon request from the individual page to go grab it. So a whole lot of stuff I just deleted, and now it's just, oh, well, once I have my content, render my content, move on, I am done. All right, so that was pretty much it for the application changes. With the exception of infinite scroll. Like now that we're only loading pages on the nice big index page for this application, as we scroll down the page, we want to keep loading more pages. So for that, I'm using Ember scroll modifiers because it's a nice, easy, fast way to do this. I've added a little intersection observer configuration here, and every time it's reached, we call last reached, which was that method in the last commit that just calls the next on the page. And that's the sum total of changes for infinite scroll here. Then I got fancy. So this PR, I'm going to skim past it a little bit, but basically what I realized was that the URLs that we generate start with a slash, but we're serving them off of localhost 4200. I could have prefixed them in the generate script and just made an assumption it was always serving on localhost, but that wouldn't be very nice if we say deployed this to GitHub Pages. When it comes to cache keys, that URL being the cache key, if your URL starts with localhost 4200, that's a different string than if you just start with a /. So this is just a dastardly little thing to say, hey, every time I get some content back, if I end up having a links property, go through all of the links and prefix it with my current domain so that I always have a consistent string key everywhere so that my cache key is consistent. If that went right past your head, it's fine. Like, that is an optimization that we don't necessarily need to care about. And that led to just one last change that I needed to make before we were back into a working state with this demo. And that was that before, we were searching the big list of all Pokemons to find a particular Pokemon by ID. And then we were preloading the image for that using this little util that was available in a different file by looking at the hires link for that particular Pokemon. The thing is, now we don't know if we have loaded this particular Pokemon anymore when we want to go preload the image, right? We might not have reached it in what we loaded from the big lists because we're paginated, so we don't know that it's there. But they all follow the pattern, so I just wrote a little utility that builds the URL out for us from the particular ID of the Pokemon, and that way I didn't even need to have it loaded. I could just work from there. So, demo. Here is, clear this up for a moment, and let's hit a refresh on here, which is obviously always a little bit risky on our very lovely tether spot. This is Pokedex running with all the changes we've done so far. You'll notice that image loading sometimes kind of a little blocky, right? You know, this is, we haven't done, we're loading a whole lot of images on this page. We're not doing any optimizations around it currently, that kind of thing. But nice and working. We can go into an individual one. Ignace had set up some really lovely animations here, playing around with transition animations and whatnot. So cool, great. We have WarpDrive working with absolutely everything that we cared about. And technically speaking, this is where I could end right now. But if I did, I actually wouldn't have shown you the one more thing. Because to this point, this is all stuff that I've talked about previously in some capacity. But what I want to show is why this architecture matters so much. Why are we pursuing a request-based architecture? Why are we pursuing a schema-based architecture? Why are we pursuing the particular separation of concerns of the request manager versus the store? Well, the first one is that it lets us do some pretty nifty little optimizations. So for instance, I can just throw in another thing into my handler here. I realized while I was playing around with this demo that, hey, the data that comes back from an individual resource endpoint is going to be identical to the data that I got from the big list endpoint in my particular example. Since I know this about my application, I don't actually need to go to network to fulfill that. So what I say here is, hey, am I a find record operation? Go check. Get me the identifier for this request. Check if I have made this request before. Oh, I haven't made this request before? Go see what the identifier is for the record that I'm trying to find. Do I have such an identifier? Great. Go peek the cache for that. If I have something in the cache for that, I'm going to construct a fake response. So here's some headers. Here's a date for it. Here's a new response object. I'm going to set that as the response. I'm going to return the data. I'm done. I never hit network. I'm just moving on. Being able to make decisions like this in handlers is really, really powerful. An example of some things that I've already found it useful for is,
hey, you want to use pagination links? That nice feature I showed you in your API has a conventional structure for how the URLs are formed for pagination, but it doesn't give you pagination links. You can use a handler to very quickly decorate any request with some pagination links on the way back that map to the structure based on where you started from. And you don't have to then get, you can stay on all the rails for all the same patterns and not have to change anything else. So I'm going to skip past actually demoing that and go into the next thing. And this is the real one more thing. We have a new package, WarpDrive Experiments. Experiments is a way of branding ideas that we think are going to shape the future of the library, but are well before adoption. Like, this is not Canary. It might even get a stable release, and still it's not really even Canary. It basically means that we're going to bake this for a while. We might rapidly or dramatically change its API at some point out from under you. We're making no guarantees at all on stability of the API because we're still figuring it out. But once it becomes stable, the project will move out of experiments and into its own package. And then that's the point you know that, okay, this is ready for adoption if you don't want to live on the bleeding edge. So I have installed that, added my TypeScript. And now I want to configure a data worker. A data worker is a way of taking all that fetch tree, so the Pokemon handler and the fetch handler in our case, and offloading the work it's doing into a separate thread. So it's no longer on the main thread at all. And to do this, we do a configuration that looks a lot like our store file. So I imported store, I imported request manager, I imported fetch, I imported JSON API cache, but I didn't import cache handler from store anymore. I actually brought it from our experiments for the data worker, and I imported data worker. And I create a store that looks exactly like the store I had in the app. Same handler chain, I'm still using a cache handler, same cache policy, same cache, same schema service. But at the end, in your module state, I'm just going to call it new data worker with that store instance. Then I created a little data worker fetch file. And in this file, I said, create a new worker fetch. So import worker fetch from this experiment, create a new worker fetch. For that, use a shared worker. Shared worker is just a built-in platform API. The location of this is data worker using URL. And it is using type module, which allows it to use ESM syntax. All this does is tell either Webpack or Vite, hi, treat this as a new entry point. This is a wholly new kind of application within the application. Here's how you find it and build it. So it will bundle everything that this data worker had required into a whole standalone executable. And when you eventually invoke this later at runtime, it will launch that executable. I come into the store package, I drop fetch because I don't need it anymore. I drop the Pokemon handler because I don't need it anymore. I import my new fetch handler. I replace my handler chain, and I am done. I have now moved all of these requests into this worker. And finally, I had to adjust my vconfig just a little bit to tell it, hey, don't do any fancy embroider specific things on these files. It's fine without them. So I'm able to do that in part because everything in Ember Data is in WarpDrive is pretty much just like standard ESM at this point. We have very, very few entanglements back to the rest of the ecosystem. So just bundling it up and tossing it in a new environment, whether that's a server or a worker, very easy for us to do. So let's check this out. Yes, I'm running an install. But hopefully the offline flag here will save me. Great. Let's see, the Vite recover. No, I'm going to restart the Vite server real quick. Cool, we're up and running. Let's come back to our demo. See if we can load. Sometimes its first build is a little unhappy. Let's try that one more time. Let's go maybe back here, hit a refresh. All right. What I'm going to do here is I am going to scope down to fetch XHR requests. If you were paying attention over here in the first round of this demo, network requests were happening. And now, network requests are not happening, but I still have my data. I can scroll, it's loading in. Network requests are not happening. I can go into things, network requests are not happening. They actually are happening, they have to be happening, right? Like you have to be questioning, what devilry have you done here? And the answer is that Chrome DevTools is actually really annoying when it comes to shared workers. My data worker is in here running in, we can find it going Chrome inspect workers, and we can launch its inspect. And if we go look at its network tab, when I refresh this, we will find out that, hey, actually, in fact, I did make a couple of requests for data. I fetched the initial list, and I fetched 126 because that was the page that was on here. So we have all our fetch requests running in a worker. But if that was all this was, it'd be a cool one more thing, but it wouldn't be as cool as what I'm going to show you now. I'm going to open up a second tab. And I'm going to keep scrolling around. It's the same worker instance. There isn't a second worker, it's one worker. Which means that if I just keep opening tabs, I didn't make any new requests here. Until I reach something that I haven't fetched yet, it's not going to load. Now I reach something I haven't fetched, so it'll load. So shared workers dedupe your requests across tab. They let you replay your requests across tab. But that's cool. We can go further. We have a persisted option here. So normally, the last tab using a shared worker closes, the shared worker itself is torn down and destroyed. But we can use the persisted option to say, hey, actually, take everything that you've loaded into your request cache and just save it for me. So we'll come in here, check out. Vite will rebuild. We're in here now. We can close out some of these tabs. I'm just going to hit refresh. Let's make sure that we have our follow-up over here. I'm going to close this out. I will hit refresh. So before, the last time, we saw new network requests occur when we refreshed, and now we don't. And that's because it's replaying it out of persisted cache. Now, this persisted cache is kind of interesting. It's using a newer platform feature. It is available far enough back in every browser that we're happy to ship it, but it's called OPFS, Origin Private File System. An Origin Private File System, our usage of it here is very simple compared to how complex it can get. Our current setup is that we are able to scope how we're using it in a way that you could tie it to specific user sessions. So for instance, if you were doing multiple accounts and you wanted to have an account switcher, you could have a completely separate store in cache by account, and it would just seamlessly switch on you when you switch the user session. And you wouldn't be able to access that data if that wasn't your session. But while that's cool, it can do so much more. The OPFS can have a sync file access handle. And that sync file access handle is capable of reading and writing to smaller portions of a buffer without loading the entire buffer into memory, which is a really convoluted way of saying that we can put SQLite into the browser. And SQLite into the browser is not something you really want to do on the main thread. right? It's a really big package. It's a really intensive package. But if we can put it into a worker, all of a sudden, worlds are our oyster. Because when we want to replay requests, when you launch a new tab, we don't want to pay the cost of loading everything back out of the cache into memory. We only want to load the stuff into memory that you're actually requesting in that moment so that you have the fastest possible boot. If we want to go local first for everybody by default out of the box, if we're running SQLite, we can write a query language that is just something that you stick in a handler where one of your handlers says, hey, I know how to handle this query locally, or I know how to persist this locally, and I'm going to use SQLite to do it. So we can write really advanced offline experiences that lift the tide for absolutely every app. The amount of configuration that will be needed to get to that point is what I've already shown here on this page. That will take any Ember app and make it a local first offline app. But there's one more thing. This demo is unfortunately all read. It's not write. There's no mutations involved. Schema record has a very interesting capability. It doesn't show its mutated state by default. It shows its remote state, or the last known server state. It is automatically a buffer. If you have written code using Ember buffered proxy or Ember change sets or any version of these things, that is basically built into schema record. With schema record, when you want to edit it, you call checkout, and that gives you an editable copy, and that's the only time that you can see the edited state. We can take the edited state and just also persist it, and we can persist it in the cache separately so that the persisted version of this thing understands this is the part that has changed, and this is the part that is canonical. Which means that you can very trivially now build forms where you don't have to worry about rollback. You can very trivially build forms that aren't polluting the global state, but automatically return to the user's last state where they were editing when they come back. They forget, they navigate away, they close the tab, they come back, the browser crashes, they come back. All of these different scenarios, we can basically out of the box make them work for you. With very little code. The only part that I would expect that people have to figure out later is if you want to do sort of like a user tried to save, but you were offline, how do I sync those things later? Like there will be a queue somewhere, and probably you will have to write some code that says, here's how I unload this queue when you come back online. But outside of those things, well, how you build applications is about to radically change if you're using these patterns. And we're not done. And I apologize for going very over here. So this commit is a little bit bigger than it should be because I had to account for a small bug in the WarpDrive experiments version of the image worker. But the code that's in the image worker in this commit is like 99% the same as the code that is in WarpDrive experiments version of this thing, and then has the bug fix. So what this commit does is we add some new CSS that says, hey, for all those images that we've been displaying that we're loading, just give them a width of 100% of their container and give them an aspect ratio of 1:1. Aspect ratio is a somewhat new API in CSS, but it is compatible back in a fairly large way, and it's just a really sneaky, nice way of saying, make sure my height matches my width. Right. So that means that, hey, you don't actually have the image's dimensions yet because it hasn't loaded. It doesn't matter. Like, it just exactly fills out the same amount of space. Then what we do is we say, hey, everywhere that we were loading an image before, instead, we're only going to show the image if we have an image URL. We use this image fetch service. We make a request against that service, and then we get the URL back from it. So the request is not giving us the image back. The request is giving us a URL back. That URL is a data URL. The service is going to go and fetch the image in the background, make sure that it's actually cached, so if you want to replay it later for offline use, it is. It's going to do all of that work in a shared worker off the main thread and then transfer just the blob URL back to you, which means that in these scenarios like are in this demo where you're loading 40, 50, 100, 200, 500 images very rapidly, instead of bogging down the main thread with all of these image requests that are coming back and getting processed, you're bogging down the worker instead. And the worker is going to get through all of the processing it needs to get through, give you these image blob URLs back, and since the image has already been parsed and processed, it's already in the buffer, the main thread has very little remaining work to do. So I'm going to skip demo on this for time, but you can go play with this if you want. It's in this PR. But basically what this has the effect of is when you're scrolling fast, those places where you were seeing really big kind of choppy lag before is still a little bit of lag, but a lot less lag now because there's a lot less work happening. And you might ask, why does Ember Data or WarpDrive want to build an image worker? Why is that an experiment? And the answer is that I look at it as a key goal for us to enable every app to be a local first offline app. I think that that is the responsibility of the data framework more than is the responsibility of the rendering framework, because most of the things that you actually need to worry about and care about to make that work effectively are related to data. So anything that is going to help an application get to being able to work in that paradigm and optimize its performance is something that I want to ship as part of its paradigm. So images are just data too. The thing is that like, if we can put WarpDrive into a worker this easily, if we can gain access to a robust request management in a worker this easily, if we can gain access to a robust cache with relationship management in a worker this easily, what stops us from using this on a server? The answer is really nothing. I have an experimental POC that takes Ember Data and does just that. The reason that we want to do that has nothing to do with putting us on the server in terms of your application development. It has everything to do with how do we replace Mirage. If you have a data framework like WarpDrive, it should handle every concern, not just how do I fetch data. It should also handle how do I test when I'm fetching data. Not just how do I use data that I've gotten back from the fetch, how do I mock the data that I'm going to get back from the fetch? We want to provide as equally good a testing story over top of real network requests using very realistic payloads as we can. Should be integral to the experience of a data framework. Well, turns out we have an ORM that is really good at building up relational data already in our library. It's our library. Why don't we just have our library do two things at once? So I have an experiment that just takes it, sticks it in a real HTTP server, and shows that, hey, you can do this, and it works. The other thing is, like, what stops us from putting this into an edge worker? Edge worker is a really interesting idea in that I don't think any other ecosystem out there right now today is pursuing this concept, but I feel like they should. The bottleneck in our applications is very rarely rendering. And so that's where RSCs and SSR have not really made sense to me. Like most of the applications that I've seen getting built, their bottleneck is in the fetch aspect. Like I want more data, I'm making a lot of requests for data, I'm waterfalling these network requests, and so it's compounding the amount of time that's being spent. I want to get ready to go to another page. I don't know what requests it's going to make, so how do I make those requests? And SSR and RSCs are a really kind of cheap way of trying to patch around that problem. But what if, via the request component and a slightly smarter router, like the one that we've been dreaming up for Ember, we could take the fetch tree completely out of the application and leave the rendering behind. Just run the fetch tree on a server. It wouldn't replace your API. This would just be a little deployable that you would put on the edge. And what it would do is basically function as a big pipe. So you make a request saying, hey, for this URL, run the fetch tree. The worker calls out to your actual API saying, here's 10 different requests I need to make. It muxes that into one response. It sends it back down. You have a little preload utility over top of links in your applications that's just doing this in the background. It's all running through a worker, so it's not bogging down your main thread. And it's capable of instantaneously hydrating the cache to get it ready for you, so that when you go to transition to that next page, it is immediate. The user experience is just amazing without you having to have done very much work at all as a developer.
So,
I went into this already. This one was going to be about local mutation, so I'll skip past. I also went into this one a little bit. This one is about OPFS and what we can do to bring local querying. And so I want to leave us just with Q&A. I've thrown a lot at you today. You might have a lot of questions. You might prefer to ask me those questions over the beer at the bar that we're probably late to. Either of those is fine, but thank you for listening to my TED Talk.